between the moon and the sun,
What?
something like that. And
It makes friction of water.
and then bam, there's tides. Whoa.
I think there's tides in the ocean because the Earth rotates around the sun, or revolves around the sun, and therefore it causes displacement in the Earth, so the water goes up and down or something.
Because of the rotation of the Earth and the moon.
There are tides in the ocean because the moon is above the Earth. When the Earth is there and the moon is here, the moon pulls the waves with the gravity and makes it happen. Because of the moon.
Tides are defined as the rise and fall of Earth's large bodies of water. These tides are caused by the gravitational pull of the moon and the sun on the Earth's surface in combination with the Earth's rotation. The moon pulls the water on the closest part of Earth's surface towards itself, which creates a bulge. On the opposite side of the Earth, the moon pulls the Earth away from the water because of the two objects' center of mass, creating a separate bulge. These bulges are defined as high tides because the effect of the moon's gravity causes water to rise on opposite sides of the Earth. Because high tides occur at the same time on two sides of the Earth, and the Earth rotates a full 360 degrees over 24 hours, there are about 2 high tides and 2 low tides every day. Because the moon orbits the Earth very slowly, it has little effect on the frequency of tides. Spring tides are especially strong because they occur when the Earth, the Sun, and the Moon are in alignment. More specifically, these occur when the Moon is in its new or full phase. The combined gravitational forces of the Sun and the Moon cause tides to be more extreme here on Earth.
Yes.
Why?
The moons of Saturn and Jupiter, Titan.
I think there are tides on Uranus.
Do you have any explanation for that?
Well, I think it's a gas planet, and with gases, I'm sure there's more tides, but it's not like water tides, like gas tides.
We're there probably.
Like where? Make a guess.
I mean,
We're there forever.
No, not after the morning.
Which I was,
Maybe-
don't get me wrong, I was perfectly fine with it.
I don't know.
You did really well.
I don't know about our solar system, definitely like elsewhere in the galaxy.
That's so cute.
I don't know.
There are actually tides much stronger than Earth's in our own solar system. Io, the most volcanically active body in the solar system, is continuously being squeezed by the gravitational pull of Jupiter. Because of its elliptical orbit, Io is subject to extreme tidal forces during its close proximity to Jupiter. Jupiter is also massive, further explaining its strong gravitational pull on Io. This tidal pressure creates extreme heat inside Io and causes lava to spew from its subsurface crust, constantly renewing and reshaping its surface.
I get a good feeling, yeah. Get a feeling that I never had before. No, I get a good feeling.
As we have seen, tides occur because of difference in gravitational pull on opposite sides of an object. Black holes are no exception. In fact, the extreme tidal force near black holes causes a stretching effect so powerful that no object can withstand it. Even between a distance as small as the length between a person's head and their toes, the gravitational pull inside a black hole would be so dramatically different on the person's opposite sides that she would be stretched out, or spaghettified. This occurs only within very strong and non-homogeneous gravitational fields, black holes being the most common example. While most people don't realize it, tides are much more than the rise and fall of water levels here on our home planet. Tidal forces are constantly at work all across our universe among stars, planets, moons, and even black holes, reminding us of the inescapable force of gravity.